Good day, great souls. Welcome back to a second session. This session we'll be looking at the quadratic sequence, and I'll be going a bit slow in this session. But just do keep note that if you find me to be a bit slow, a bit redundant, it's all in efforts to make sure that you understand the work and that it sticks in. Okay, so boys and girls, you guys did have a look back. Did have a moment whereby you guys encountered a quadratic sequence, be it in the parabola or when you guys were doing number patterns and functions last year in grade 11. So boys and girls, just a quick recap. A quadratic sequence is essentially a sequence in which the second difference is a constant or a common difference. And I want you to know that the general term for a quadratic sequence, boys and girls, is T of n is equal to an squared plus bn plus c. And the question will usually say, provide the general term or provide T of n, and you would have to give the formula of that sequence in this format. And I want you to, because some people tend to tend to panic, I just want you to remember that you do remember this formula. This formula is not new because this formula is essentially the same thing as your quadratic formula, but it's just that we've changed the variables from x to n. Now, how do we prove that a sequence is quadratic? For first of all, what we would do is we would essentially find the difference between the first consecutive terms in the sequence. Then we would find the difference between the results of step 1, and then if the answer is the same, therefore quadratic. For example, boys and girls, let's look at this question here. When we look at this question here, we see that here we're adding consistently, we're basically adding numbers. So from 0 to 1, we added 1. From 1 to 3, we added 2. From 3 to 6, we added 3. From 6 to 10, we added 4. That's step 1 done. Step 2, it says find the difference between the results of step 1. So we would go and find the difference. From 1 to 2, we add 1. From 2 to 3, we add 1. And from 3 to 4, we obviously add 1. So we see that there's a common difference of 1. What we can see is that in order to get here, we added 1. In order to get here, we add 1. Okay, that's what I want you guys to understand. And therefore, we can say that this is quadratic. And in a test or in an exam, if they say prove that it's quadratic, you would have to do this whole procedure, and it's usually 2 marks. You get a mark here and a mark here. Okay, that being said, I want us to move to finding the equation of a quadratic sequence, boys and girls. Now, how do we find the equation of a quadratic sequence? Follow exactly what I say. Write this down in your book or wherever. First step, we would first, as you can see, say that 2a is equal to the common difference. So 2a is equal to the common difference, then solve for a. The second step, we will say 3a plus b is equal to the first difference of the first 2 consecutive terms, and we would solve for b because we'd already have a from step 1. Step 3, a plus b plus c is equal to the first term. We would have in this case we would already have a, we would already have b, so we would solve for c. Now, let's quickly look at this. Step 1. In this equation, let's look at this example and find the T of n, or the general term of this. Step 1, we say that T of n is equal to the common difference. The common difference in this case is 1. And when we solve for a, we find that a is equal to a half. Perfect. Then step 2, we say 3a plus b is equal to the first difference of the first 2 consecutive terms in the original sequence. So 3a plus b is equal to 1. We have a. 3 times a half plus b is equal to 1. So we would have 1.5 plus b is equal to 1. Therefore, b is equal to negative a half. So now we have b. Now we're moving on to c. A plus b plus c. As the step says, a plus b plus c is equal to the first term. The first term, which is 0. So therefore, a half plus negative a half plus c are equal to 0. Therefore, we know that a half plus negative a half gives us 0. Therefore, c is equal to 0. All right. Now we have a, b, and c. And last we have to do, we just have to put it into our general term, or general formula, or standard form. So therefore, t of n is equal to, we said that a is a half, n squared, minus a half, because b is equal to negative a half, plus c, which is 0. You can write it, or you can choose to leave the 0. It really does not make a difference. And that's where you get your 4 marks. All right. Perfect. I hope you understand. So, boys and girls, it's quite important for you guys to essentially learn the way in which you approach a question, and then from there on apply it. So you can't just say that you're going to start doing questions. Learn the theory behind the work, then do the questions. And it's very important. I would advise that you write this down and this down, as these guide you on ways to solve these questions. Now, boys and girls, as a person that's very, very, very inquisitive, I'm going to go read a document by the Department of Education, and essentially analyzes what learners get wrong and what learners essentially get wrong in exams. And that being that learners forget the basic theory with regards to determining the nature of roots. So if, boys and girls, we look back and get a quick recap on our grade 11 work, we'd remember that when we determine the nature of roots, we would first have to find the discriminant, or the value of the discriminant, and that would tell us a lot about the nature of roots. So what is the discriminant? The discriminant, otherwise known as delta, is equal to b squared minus 4ac. And where does this come from? Some might ask. Well, my little stickman here has been thinking about a formula, and that formula is the quadratic formula, b squared minus 4ac, determining the nature of roots. So when you look at the table here, when delta is more than 0, as the table says, the nature of roots would be real and unequal. If delta is equal to 0, they would be real and equal. If delta is less than 0, they would be imaginary. And if delta is more than 0 and a perfect square, rational. If delta is more than 0 and not a perfect square, they would be irrational. So, boys and girls, I would advise that you know this table off by heart, because this will link in not only in this topic, but it will also link into your functions as well as calculus. Now, in B, I did write here, notice, like you know, that person that you're currently dating is not the one for you, but you just keep forcing. So know that. Keep it a fact. Okay. So, that being said, boys and girls, I want us to look at this last piece of information before we tackle questions. Boys and girls, when we think back on the parabola, remember when we had a parabola, we would talk about a maximum and a minimum value. And this would refer, when looking at our coordinates, because, we'd be plotting the graphs, this would refer to our y value. Okay. So they would usually ask us about a maximum value or a minimum value in a graph, and we know that they refer to the y value. Now, when asked to give or provide a maximum or minimum value in a sequence, we would use the formula x is equal to negative b over 2a. Now, this is a shortcut, boys and girls. You can complete the square. That's a long way, but you can do that. Or you can just apply this formula, which is very quick and easy. Now, the formula would be using step 1. Use x is equal to negative b over 2a. The value that you find here for x, you would plug into your quadratic sequence or your quadratic formula, that being t of n. Alright? And then the answer obtained from plugging it in is your maximum / minimum value. Okay? But we know that we would have a maximum value when we of rounding, or basically when the gradient is less than 0. And when the gradient is positive, we are smiling, a smiley parabola, we would have a minimum value, a minimum y value. Now let's quickly tackle questions, boys and girls. That being said, I know it's a lot of information. This page, I would say, is very important in order for you to ace this section. That being said, boys and girls, question 2.1. Let's tackle question 2.1. So we see that we are given a number pattern, and the first question asks us, we see that we're adding as we go along. The first question asks us is to show that this is a quadratic number pattern. Now think back on the first thing I told you guys to do when proving. Okay, 6, 13, 22, 33. Okay. We would then find the difference between the first term and the second term. So from 6 to 13, we added 7. From 13 to 22, we added 9. And from 22 to 33, we added 11. Now from 7 to 9, we added what? We added 2. And from 9 to 11, we added 2. This alone tells us that we're dealing with a quadratic function. So we get a mark here and a mark here. 2 marks, easy marks, I told you guys. Now, let's move on to question 2.2, boys and girls. Question 2.2 asks us to write down the values of x and y. It's 2 marks, so it should be easy. We shouldn't go for a long way. Okay, write down the values of x and y. So we said we have 6, 13, 22, 33, x, y, blah, blah, blah. And we said that we add 7, add 9, we add 11. Okay. And then from there on, we add 2 to each term. Okay. So we could see here, boys and girls, in order for them to essentially, what's happening is that we're adding 2 to the next, to each and every term to get the next term. So for example, for example, we added 2 to 7 to get 9, and then from there on we say 13 plus 9 gives us 22. Another example, from 9 we added 2, we got 11, and then we add 11 to 22, we got 33. So what we're going to do, we're going to add 2 to 11. So what we're going to do is we're going to add 2 to 11, and when we add 2 to 11, so we're going to add 2, so let me just quickly use a different color pen so that we're able to see what I'm talking about. So we add 2 to 11, we get 13, right? Perfect. And then from there on, 13 plus 33 gives me 46. Alrighty. From 13 to, essentially what we do then to get to the y value, we add 2 to 13. So 13 plus 2 is 15. Now 15 plus 46. So let's quickly see here. Okay, let's see. Okay. 5, 6, 61. Y would be 61. Okay. So therefore, we would write there x is equal to 46, y is equal to 61 as our final answers. That being said, let's move on to question 2.3. 2.3 will help us actually determine whether what we're saying makes sense. Does it make sense though? Let's quickly check if our answers make sense for question 2.2. So 46 minus 33. 46 minus 33 gives us 13, right? 46 minus 33 gives us 13, right? And then, okay, perfect. Makes sense. Now, 61 minus 46 gives us 15, perfect. And it shows that we're adding 2 to each and every term. Perfect. Now, question 2.3 asks us, determine the nth term. Now, what is the nth term, boys and girls? That's your T of n formula. That's your general formula. As well as, so we're not only determining this, we're also determining the 160th term. Okay, perfect. So we already know, we've already I guess, digested or broken down our function that's given. So our step one to getting the T of n would say essentially to get our T of n would essentially say that 2a is equal to the common difference, which is 2 in this case. So therefore a is equal to 1. From there on, we would then proceed to talk about getting the second part, which is getting b. And we said that we follow the formula 3a plus b is equal to the first difference of the first two consecutive terms in the original sequence. In this case, that would be 7, right? Right. So it's 7. 7, yeah. And then from there on, we already have our a, excuse me, and a is 1. So b is equal to 7 minus 3, which is 4. Now let's solve for c quickly. We said that c, a plus b plus c, which is our third step, as I taught you guys, is equal to 6, which is the first term. A plus b plus c is equal to the first term. We have our a, which is 1. We have our b, which is 4, plus c is equal to 6. Therefore, c is equal to 6 minus 5, which is 1, when you solve for c. And let me just quickly put it here. Therefore, T of n is equal to 1n squared plus 4n plus 1. That's our general term. But are we done? No, we're not. And why are we not done? We are not done because we still have to find, as stipulated in the question, we still have to find the 160th term. So, therefore, T160 is equal to 1 times 160 squared plus 4 times 160 plus 1. T160, boys and girls, is equal to, essentially, we know that when we square something, it's the same as saying 160 multiplied by 160, and that's 25,600 plus 160 times 4, which is 640, plus 1. And that all added together, 640 plus 1 plus 2,000, plus 25,600 gives us 26,241, and that's your final answer. And in this case, you would get a mark for your final answer. So it's, how many marks is it? It's 5 marks. A mark for your final answer, a mark for A, finding A, a mark for finding B, a mark for finding C, a mark for substituting 160 into your formula. So that's 5 marks. 5 marks. And in question 2.2, you would get a mark for X and Y. That would be 2 marks. Perfect. Okay. I hope it's all going well. And let's move on to question 2.4, boys and girls. Question 2.4. Let's see what question 2.4 has for us. It says, determine which term equals 397. So, when they say which term equals 397 or which term equals a certain number, it means the formula that we got for the general term equal this specific number being 397. So therefore, 397 is equal to n squared plus 4n plus 1. 0 is equal to n squared plus 4n plus 396. Right? Then we'd use our quadratic formula. N is equal to negative 4 plus minus square root of 4 squared minus 4 times 1 multiplied by 396 all over 2a, which is 1. Therefore, a1 will give you one number, and or n will give you another number. So they said which term. So here you'll get a positive and negative number. The negative number can never equal a negative because we're dealing in positives. We have term 1, term 2, term 3, term 4, term 5. We don't have a term -1. Okay, so the positive number here when solving will give you the answer, boys and girls, and that will be 4 marks. You'll get 1 for rejecting, you'll get 1 for your final answer, 1 for substitution, and 1 for standard form. 4 marks. Okay. So question 2.5, boys and girls. Question 2.5 asks us to determine the nature of roots for the sequence. Now, determining the nature of roots for a sequence, boys and girls, what do? We use delta. We use the discriminant. Think back to grade 11. Never forget this. Like I said, remember this like you know yourself. Know this like you know yourself. Okay. Delta is equal to b squared minus 4ac. And we have b in our formula. We have our b value. Our b value is 4 minus 4. And our a value is 1 and our c value is 1. So 4 squared is 16 minus 4, which gives us 12. So, and then after getting the value of delta, boys and girls, what do? Because we listened to what Mpo said, we will remember the table. And then we go back to our table, we remember, we look, okay. So we know that delta is 12. So 12 is more than 0. Okay. So delta is more than 0. Just fits our list. So this describes the nature. But is delta equal to 0? No, so this does not apply to us. It's not less than 0, it does not apply to us. And then we're like, okay, is delta more than 0? Yes. Is it a perfect square? No. Is it not a perfect square? Yes. So these describe the nature of roots. So our roots are real, unequal, irrational. Therefore, roots are unequal, irrational, excuse me, just make sure, unequal, irrational, and real. Irrational and real. Easy 2 marks. This is a level 4 type question. So if you're aiming for the 100% in this section, good for you to know this. Okay. Now, the last question, boys and girls, before we move along, question 2.6. And question 2.6 says, does the sequence have a maximum or a minimum value and provide that said value? So remember, boys and girls, our general formula is T of n is equal to n squared plus 4n plus 1. So this is our formula for the quadratic sequence. And we know that when a is positive, we are smiling. So therefore, we will be having a minimum value. And how do we get that set minimum value? We follow the steps. The most important formula I taught you again. We plug it into our formula. X is equal to negative b over 2a. We then move on to set that x is equal to negative 4 over 2 times 1. And x gives us negative 2. Okay, then we take the same negative 2 and we plug it into T of n. So we'll have negative 2 squared plus 4 times negative 2 plus 1. And we'll have 4 plus 4 times 2 is 8, but this is a negative number, so we'll have a negative 8 plus 1. And we would have, therefore, 5 plus negative 8. That gives us negative 3, boys and girls, if I'm not mistaken. Yes, because this one leave us with a negative 4, negative 4 plus 1, negative 3, 3. Therefore, the minimum value is negative 3. And you would get 3 marks. A mark for saying minimum, a mark for getting to the answer. And that's it, boys and girls. That's it for today. In the next video, I'll be showing you guys, essentially we're working through more questions for both arithmetic as well as quadratic. Now, boys and girls, remember, always know your foundation, and your foundation is your theory. If you know this, you're able to tackle this. And I've been able to show you how I go back and revert to what I've taught myself. Okay. So boys and girls, thank you very much for subscribing. If you aren't, please do subscribe. Thank you very much for watching, and I wish you all the best of your studies. Remember, keep God the center of it all, and everything will go well. Okay. Cheers, guys.